Okay, so I've arrived in beautiful Lisbon, Portugal for Cosyne 2024. So Cosyne is my favorite conference. I don't go to that many conferences actually, but I really like going to Cosyne. I think it's really always a really inspiring visit. Lots of really cool research going on in computational and systems neuroscience. That's where the name comes from. And I thought it would be really fun this year, before the conference starts, it all starts tomorrow, to try to predict what types of posters and talks are going to be at the conference. So I haven't seen any of these yet. I haven't heard much about what's going to be on. So I thought it'd be fun just to try to guess ahead of time, what the big ideas and work is going to be about this year. If for no other reason, then it'll be really funny to see how wrong I am in a few days' time. So yeah, so I'm just going to make some predictions, and we can revisit these as I go through the conference and um, update on what's going on. Okay, so the deadline for applying to this conference was in November, and so that'll be a full year since ChatGPT came out. So I think this time around, so last time in Cosyne 2023, there wouldn't have been enough time for people to really start thinking too much about transformers, or ChatGPT being really wowed by it and wanting to see if they can do something with it. Although transformers have been around since 2017, but I think their big impact has been since ChatGPT in, I guess, about 2023. So I think this will be the very first time at Cosyne, I think, where transformers are going to be really getting factored into everything. So people are going to be looking at what parts of the brain could be doing transformer-like operations, or somehow applying large language models, things of that nature. So I think my one prediction for the big new thing at Cosyne this year is going to be transformers. So, and I'm going to put some numbers on it. So I think it's going to be about 5% of posters, or let's say abstracts, are going to have the word transformer in them. So I'm going to say 5%. And I did some post hoc calculations about where that number would come from. So let's say 2/3 of the abstracts are on the computational side, rather than a more neuroscience, kind of experimental neuroscience side. So 2/3 of those, and let's say, I don't know, let's say a third of those authors will have tried something related, and let's say a quarter of those will have worked. So a third of the authors will have tried to do something with transformers. A quarter of those will have worked. And what do we get out of this? So that's this is going to be over 2/36. 1/18, that's about 1/20, so about 5%. So I think here's a rough, I would barely even call it a calculation, but I think 5%. So as soon as the abstract come out, I'll do a search through and see what fraction are about transformers. But I think that's going to be one of the big ideas. So people are going to be talking about that, trying to factor that into how we understand the brain. I think that's really exciting. I actually know, so full disclosure, one of the guys in one of our neighboring labs, he's actually giving a talk on one application of transformers. But I think even if he wasn't, I'd be pretty confident that this is going to be a really exciting idea that people are, especially with after ChatGPT and transformers with a T in GPT, I think transformers, and also stepping back to large language models, I think that's going to be a big part of what people are going to talk about today. So I think that's going to be the big new idea that people are going to be discussing. The other items I think are going to be just continuing on kind of some of the themes from last time. So I think one of the big themes was ever finer recording and analysis of behavior. So let's just say ever more detailed behavior. And there are some really amazing tools now for analyzing behavior, just that don't really require nearly as much human supervision, and you'll just get behavior really registered and just coming out, and they're just kind of begging to be analyzed. So I think there's going to be even more of that. And how are people analyzing these days? So they're going to be analyzing this with more and more complicated RNNs. So trying to get RNNs to solve the same tasks and see how the RNNs do it. Also, and I guess I guess they're going to be also trying to understand this behavior using, let's say, broadly kind of manifold learning. You know, so we're going to be trying to take this kind of high-dimensional behavioral data, project it down onto some low-dimensional latent variables, trying to map out the manifold of the latent variables. So we saw a lot of that last time. So there's going to be lots of analysis tools. Zebra was very prominent last year was a keynote talk of taking behavior using contrastive learning, where you can just indicate that, let's say, neural activity that are far apart in time should be put in different categories, and things like that. Simple tools like that you can actually apply to most data sets give you some really interesting structures in the latent variable space that then you can try to analyze with things like RNNs and neural networks and other types of neural networks and deep networks. So I think we're going to have more detailed behavior analysis with RNNs and kind of this manifold learning of the data itself. So trying to kind of take that high-dimensional data set that you're getting and map it down to low-dimensional latent variables that live on a manifold, trying to understand that manifold. So I think that's going to be, that people are still going to be doing that, and we'll see probably even more advanced examples of that. The next thing, so one of the really interesting ideas was, okay, so once you have your RNNs, how do you, or a deep network, how do you understand it? And I think one of the interesting talks last year was about using ideas from sparsity. So trying to explain, if I recall correctly, I was trying to have kind of sparse latent variables that could map onto human interpretable motifs, let's say, in the behavior or in the dynamics. So I'm hoping that some of that has that work has continued. So let's just put that under interpretable. Interpretable, let's say, deep learning for I don't know, neuroscience. I know it's kind of broad, but that's what I think. And last couple of themes. There's interesting complementary ideas that seem to be happening and were, I think, quite prominent last year. One is this idea that's been kind of really picking up steam in the last decade, which is this idea of computation as dynamics. And that's something that actually links up to this. So the idea is when we train neural networks to solve tasks, and then we try to understand how the neural networks are solving those tasks. Well, we can actually use the tools of dynamical systems to, for example, to look at, for example, the basins of attraction of the dynamics and to see kind of where the stable manifolds, the unstable manifolds are, that then allow you to understand the behavior as motion between these portions of the state space, and then trying to map that onto computation. So kind of stepping back from, okay, I have like 100, maybe I have 1,000, 1,000 neurons, trying to explain some kind of behavior, and then saying, well, actually, so we can, if we look at, let's say, where the critical points of those dynamics are, then we can actually understand the solution that the networks come up with in terms of those critical points. So maybe, let's say when the stimulus comes on, a previously stable point of the system has now become unstable, and now the dynamics are driven somewhere else, where based on some input, again, the system will get driven one way or the other. So trying to understand, essentially describe the dynamics that we see in terms of ideas from dynamical systems, and kind of doing that in the hopes of, I guess, simplifying it a bit, and I think also what's been really interesting has been this idea of, I think there's a paper, I haven't read this paper, I really should, but that the brains of different animals solving the same task, they show the same kind of dynamical solutions. So it's kind of giving some insight into neural computation and how that's done in terms of dynamical systems. So I think that's going to be big. It was big last year. I think it'll still be big this year. And finally, I think, so how are these computations implemented? So I think a big theme, an ever bigger theme, and not just because I come from a lab that's really into connectomics, but I think connectomics it's getting bigger and bigger. We're getting larger and larger data sets from that approach. So we're and ultimately this is kind of where things are going to go, right? We're going to be able to analyze brain tissue and tell you what all the synapses are. Hopefully, there's something about the strength of those synapses, and it's going to be the really interesting aspect is going to be kind of connecting the connectome to computations, as dynamics or whatever methodology we want to use to understand neural computation. It's ultimately going to be implemented through synaptic weights and the strength of those the strength of those connections. And so I think making the connection between the connectome and the computation is going to be, I think, a big theme. And we just saw before I came, it was I think a paper in Nature that was talking about this. So I think we're going to see some really. I'm hoping we see some examples of that. So connectomics, how connectivity constrains computation, and kind of linking that, and maybe even linking it kind of to behavior. That'd be really amazing. So I think that's one thing we're going to see. And finally, so I did my PhD on insects. So I'm really excited, and I saw a couple of Nature papers actually just recently on understanding behavior in the fly system. So in the fly, what's really cool is they actually have the connectomes now, and they've in recent years they've been able to really map lots of really interesting kind of, let's say, navigation related behaviors, and just look at the whole circuit, from one end to the other, from the input to the output, and really, I think, really give some very interesting insights into neural computation. I think some folks think that, well, the insect systems are a bit simple, and I think the insights there, maybe while they're like always really quite beautiful, maybe they don't apply to larger systems. But I actually think my hunch is that actually what we're seeing there are some really really fundamental aspects of neural computation. So, for example, how are for a simple case, how are like circular variables represented? How is the motor system modulated by various circular variables? Let's say you want some kind of head direction or some kind of navigation related variables. Is that going to be fundamentally different in vertebrates than in the fly? My hunch is it's not. But either way, I think the work there is always really beautiful. So I'm really looking forward to I guess just insights from insects, maybe like worked examples, basically. Worked examples of neural computation. So yeah, so I'm hoping we see some of that. So yeah, I think that's quite a lot of predictions. I think I have so many predictions here that I can't possibly be wrong. But I thought it'd be fun just to kind of get my head into that space. So yeah, so I think transformers are going to be a really big thing this year. So I'm going to guess 5%. 5% of the abstracts are going to have transformers in them. Even more detailed behavior, I think that's just the way things are going. This analyzing behavior with RNNs, trying to understand how things are done using deep networks and recurrent neural networks. And also, trying to understand this behavior by kind of mapping it onto manifolds. So, these kind of low dimensional projections, nonlinear projections of the high dimensional activity. I think in trying to interpret what these networks are doing is going to be important. So hopefully there'll be some progress on that. I think maybe from directional sparsity, but who knows? And then these two aspects of computation as dynamics and its implementations in the connectome. I think that's going to be really quite interesting. So we'll see where that shows up. And finally, I think I'm just really excited about just seeing more beautiful work from the insects. I think the work in the fly is just always really inspiring, really, and it really just, I think, as I said, sheds a light on neural computation. So I'm really looking forward to that. Okay, so I think that's it for my predictions, and I'll try to revisit these as we go to see how many of these came to pass. I mean, I don't know if these others really count as predictions, but let's see how many of these boxes we can tick throughout the conference. Okay, so I guess yeah, see you shortly.